All right, we're looking at doing three things today. The first thing we're going to do is find a reference angle of a given angle. Then we're going to find the six trig functions of an angle given a point on its terminal side. And then we're going to find trig functions of quadrantal angles. Those are the three things we're looking at doing today. So we want to get started with figuring out what a reference angle is. Okay, reference angle. First thing you need to know about a reference angle is that two things must be true about it. It must be an acute angle and it must be positive. A reference angle must be acute and it must be positive. Christian, remind everybody what it means to be acute.
It means that it's less than 90 degrees.
My angle must be less than 90 degrees. So if you're looking for a reference angle, you better be giving me an angle that is less than 90 degrees, and it better be positive. So if I ask you to give me a reference angle, please make sure it's at least those two things. All right, so for instance, let's start with the angle 135. Well, no, let's change that because I want something to be a little bit different. Let's see. Let's go with 150. 150 degrees. We want to find a reference angle of 150 degrees. All right, and I will already tell you that it is 30, and then we'll look at how I got 30. Does anybody have an idea of how I got 30?
You subtract 150 from that 180.
I subtracted 150 from 180, and I got 30. That is correct. Okay, so let's draw it so you can visually see what a reference angle is. So 150 degrees, what quadrant is the terminal side end up in?
2.
And quadrant 2, is it closer to 180 or 90?
180.
It's closer to 180. It's about right here. So there's 150 degrees. Okay, the reference angle that we found is 30 degrees, and it is located, it is the angle right there. Okay. So does anybody have any thoughts they think the reference, what we need to do to find a reference angle? Anybody think they have a decent idea of what we're going to do to find reference angles?
I thought 30 was the reference angle.
30 is the reference angle, but what are we going to? What's our approach going to be to find the reference angle?
Take 3 degrees you're given and subtract from 180 or 90 or something.
So
Okay.
180 subtract 80.
All right. Here's your next detail about a reference angle. A reference angle is always formed between the terminal side and the closest x-axis. Okay. It is always formed between the terminal side of your angle and the x-axis. We never use the y-axis. Okay. So that'll change what you said just a little bit. One of the only two numbers we're going to use.
180.
180 and 360. Okay, so we're always going to figure out how far is my terminal side away from 180 or 360. That's how we find our reference angle. So let's try another one. All right, let's say I want make sure that so 240. All right, so let's find a reference angle for 600 degrees. So I want to find a reference angle for 600 degrees. Thoughts on what I need to do to make this happen? Draw it? Okay, do you know where it's at? Or what you can do to figure out where it's at? Subtract 360. So the first thing you want to make sure of is that the angle you're going to find a reference angle for, that angle needs to be between 0 and 360 to begin with. So I'm going to find that. So if I subtract, that ends up giving me an angle of 240 degrees. So now I should know where 600 is at. Where is 600 at? It's in quadrant 3. Okay, and is my terminal side closer to 180 or 270? It's closer to 270. So it's going to be about right there. Since it's 600, that means I go all the way around and back to it. So there's 600 degrees. So what is the reference angle of 600 degrees going to be?
60 degrees.
60 degrees is correct. So my reference angle is right there, and it's 60 degrees. How'd you get 60 degrees, Kendrick?
Subtract the terminal side and the x-axis, the nearest x-axis.
All right, and what's the value of the nearest x-axis? How did you get 60?
I used the 90-degree angle.
You used a 90-degree angle.
Wait. I don't know what it is. I think I subtract 180.
180 is correct. Okay. If I'm dealing with an angle that is on the left side, what are we always going to use to find a reference angle? We're always going to use 180. If we're dealing with an angle that's on the right side, what are we going to use? We're going to use 360. Okay. So what's our approach if we're finding a reference angle? What's step one? Figure out where the terminal side is at, and usually, in this case, what do we have to do to 600? We need to make sure we start with an angle that's between 0 and 360. Once it's between 0 and 360, then we know where it's at. Once we know where it's at, then what do? We find the nearest x-axis, determine if I want 180 or 360, and then we subtract. How far is it away? Okay. Make sure the angle you give me is acute, and make sure it's positive. So that's why we like 60. Let's try another one. All right, so let's try. Let's try negative 405 degrees. Negative 405. So, Bobby, what do we do first? Add 360. So, if I add 360, I end up with negative 45. Do I know where it's at now, or do I need to add 360 again? I know where it's at. Where's it at, Sky? It's in the fourth quadrant. Okay, so I know 45 is right there, and it's a negative, so it's going to go all the way around and back to it. So that's negative 405. Okay, I'm looking for the reference angle, though, which needs to be positive and acute. Matthew, what's the reference angle going to be?
45.
45 is correct. Very good. So I'm wanting to know how far is this terminal side away from that x-axis, and it is 45 degrees away.
That's weird.
All right, let's try one with radians. All right, I want to find the reference angle for 7 pi over 12. 7 pi over 12. Close. Alright, so let's change it 2 degrees. So 180 over pi, and I end up with, I believe we end up with 105. We'll work it out. So, Gage, what do I know about 105?
It's in the second quadrant.
Closest to 90 or 180?
To 90.
90. It's very close to 90, so it's about right there.
Mhm.
So there's 105. So I'm interested in the reference angle, which is right there. And how much is that reference angle?
75.
75. Okay. Does 75 follow my 2 conditions?
Yes.
Yes, it's acute and it is
Positive.
positive. Questions on? Yes, Nick.
Does it have to be a degree or can it be written in radians?
It can be written in radians.
But it doesn't have to be.
Doesn't have to be. You know what that would be?
5 over 5 pi over 1.
Okay, how'd you get that?
You just subtract 12 by 7.
Good, very good. All right, now let's see what the use of a reference angle is. So let's say we go back to, we did 150 earlier, didn't we? So 150 was about right here. And the reference angle we found was what?
30.
We found was 30 degrees. Okay? So what I want to figure out is, I want to see what sine of 150 and sine of 30 equal. I want to see what those two things equal. So I go to my calculator. Eventually. Get it. There we go. All right, I'm gonna go to my calculator, and I'm gonna put both of those in there. So I'm gonna do sine of 150, and I'm going to do sine of 30. And we should notice something. What do we notice? We get the same value. Okay. Let's do the same thing with cosine. Cosine is going to be slightly different. So cosine of 150 and cosine of 30. Okay, what do you notice there?
Exact opposite.
It gives me the same number, but the original one is negative. So, what's true about the reference angle, or what's the usefulness of a reference angle? Reference angle is always going to give me a positive value, but what's the bigger concept here that we want to notice?
You can find the other angle.
I can figure out what sine or cosine or tangent or any of the six trig functions are of a big angle by finding the six trig functions of that small angle. Okay? And we're not going to get way into it today on the usefulness of it, but when we get to it tomorrow, you'll see why it's very important. But what we want to notice here is that a trig function of a reference angle is the same number as the trig function of the actual angle. We get the same number. Now, the actual angle may give us a negative answer, but what we want to notice today is it gives me the same number. That's the first thing I want to notice. Okay, so that is finding a reference angle of an angle. Okay, what do we do first? Sometimes it's necessary, sometimes it's not. What's one of the first things we need to make sure of with our angle? It's between 0 and 360. Once it's between 0 and 360, then what? We subtract it with 180 or 360, and we always have to make sure our answer is what? Acute and positive. All right, so that's reference angle. Now let's look at the next one. Let's look at the next one. Six trig functions of an angle on a terminal point on a terminal side. All right. So this time they're going to give us a point that is on the terminal side of the angle, and from that point we want to find the six trig functions. Okay. So on these first couple we're going to draw it, but I want you to eventually be able to get to where you can do this problem without drawing it. So 3, -8. So we'll say that point right there is 3, -8. And what else is happening with that point? What does the problem say is happening with that point?
So on the terminal side.
The terminal side goes through that point. So the terminal side goes through that point. So I'm looking at this angle. Okay, so I want the six trig functions of that angle. But what did we just learn with our reference angle?
You get the same numbers and just find the reference angle.
I can get the same numbers if I use the reference angle. So where is the reference angle located? Right here, correct? So I've got a reference angle that's right there. What I want to do is I want to use the point on that terminal side, and then I want to draw a triangle with my reference angle. So if I draw a triangle, I now have a right triangle. And what else do I know about this triangle?
It's got a side of 3 and a side of 8.
It's got a side of 3, and actually we'll want to say this one has a side of -8. Okay? And once I have two sides of a triangle, what can we do to get the third? Pythagorean. Okay? Which side is it I'm searching for? The hypotenuse. Now, a new variable we want to use on the hypotenuse is r. Okay? We're going to call our hypotenuse r when we're dealing with problems like this. So
Why?
let me get down the road a little bit, and then I'll tell you why.
Why would you do that?
Okay. So I have 3 squared, which is 9. I have negative 8 squared, which is 64. So I have r squared equals 73, which means r equals the square root of 73. So we have figured out the hypotenuse is the square root of 73. Okay. Once I have that, I have everything I need to get my 6 trig functions. Okay. So what is my opposite side?
8.
Negative 8. What's my hypotenuse? Square root of 73. What is my adjacent side? 3. What is my hypotenuse? Square root of 73. Do I need to look at that anymore?
No.
No. So this gives me negative 8 over 3, and then all of my reciprocals. So I have found the 6 trig functions of the angle whose terminal side goes through the point 3, negative 8, is what I found. Now I want you to notice something. What side is that right there? That's the adjacent, which ends up being 3. What spot is that in the ordered pair? That is in the X spot. Okay, what side is this one? The opposite, what spot is that in? That is in the Y. I want you to notice that and then keep that in mind when we get to the next problem. Alright, so what we did was we drew it, we found the hypotenuse, and then we got the 6 trig functions. Let's try another one. This one we want the point negative 2, negative 1. Negative 2, negative 1. So let's plot it. So negative 2, negative 1. I'm looking at an angle that looks like that. But I just want to look at what? I just want to look at the triangle that is formed right there. So what 2 sides do I know of the triangle?
Negative 1 and 2.
I've got a negative 1 right there, and I've got a negative 2 right there. What do I want to find next? R. And R is my hypotenuse, so R squared is going to equal 4 plus 1, which means R is going to equal the square root of 5. Once I have R, I have everything I need. Alright, so what's sine going to be? Negative 1 over radical 5. What's cosine going to be? Negative 2 over radical 5, which means tangent is
1/2.
1/2. Take the reciprocals. Which gives me that. And again, we want to make the same observations as the last one. What side is 2?
X.
It's adjacent, which is in the X spot. And what side is opposite? It's in the Y spot. And that will always be true. Yes. So I do not have to graph it. And we're going to do that on the next one. Okay? So what we need to notice is, and this is where the R comes into play, is there's another way to define our 6 trig functions. And that is in terms of X, Y, and R.
Does this have to do with the unit circle?
Meaning what?
The unit circle?
Unit circle will eventually get to that, yes. Okay, so what's our another alternative definition of sine going to be? Y over R. What is cosine going to be? X over R, and then everything else falls into place. Y over X, X over Y, R over X, and R over Y. So, as Sakaya said, we're going to be able to do this without drawing it, and that's what we're going to do on our next problem. Okay? But we need to notice that the X value always goes with which trig function?
I'm just kidding. Cosine.
X value goes with cosine, and the Y value goes with sine. That's a connection we need to make. X goes with cosine, Y goes with sine. Alright, so let's try one more, and this time we're going to do it without the graph. So let's do -3 and 5. So we want the 6 trig functions of the angle whose terminal side goes to the point -3, 5. Alright, so what do I want to do first? Just like I did on the first two. Find R. Pythagorean theorem to find R. So R squared equals 9 plus 25. R squared equals 34. R equals square root of 34.
Thank you.
Okay, and then what's our definition of sine?
Y.
Y over R, so that's 5 over radical 34. Definition of cosine, X over R, and then everything else falls into place. And there are 6 trig functions of the angle whose terminal side goes through the point -3, 5. Okay? So find your hypotenuse, and then everything falls into place. And that leads us into the last thing we want to cover today, which is we want to find the 6 trig functions of a quadrantal angle. Anybody have any ideas of what we're talking about with a quadrantal angle? There are 4 of them. Anybody else have any thoughts? Our quadrantal angles are 0, 90, 180, and 270. So we're talking about the angles that lie where? In between, on the axes, but in between all the quadrants. So quadrantal angles are the angles that are in between the quadrants, that don't lie in any particular quadrant. Okay, and we can also come back and say that this is also 360, since they're in the same spot. We also need to go around and talk about radians. So we're going to do 0 radians. What is 90 in radians? Pi over 2, 180 is pi, and 270? 3 pi over 2, and when we get all the way back around, we're back to 2 pi. Okay? And to get our trig functions, we're going to do exactly what we did on our last problem. Because what can we find, or what can we find on any of these quadrantals similar to what we just did the last type of problem? What did we use to find our 6 trig functions on the last type of problem? We used a point. Okay? Can I find points on these quadrantals? Yes, and we just figured out that if I can find a point, then I can find everything I need to find my 6 trig functions. So that's what we're going to do here. So let's do sine of pi over 2. I want to figure out what sine of pi over 2 is. Okay, and as we just talked, to be able to find sine of pi over 2, what do I need first? Before that, we need a point. Okay, so what is a point that is on the terminal side of pi over 2? Any point that's on, there's a ton of points on that terminal side. Just give me one of them.
2, 3.
Say it again.
2,
2, 3 does not give me on pi over 2. 2, 3. 2, 3 will put me somewhere over there. I need something that is on pi over 2. 0, 1. 0, 1 is a great one. So 0, 1 puts me 0, 1 puts me on the terminal side of pi over 2. Everybody agree with that? And as we just saw, if I've got a point on the terminal side, I can find everything I need to find my trig function. So what do I want to find next? R. So I have r squared equals 0 plus 1. So that means r is also going to be 1. Because the square root of 1 is 1. Alright, so now I've got everything I need. What's the definition of sine? Y over r. So my y value is 1, my r value is 1. So that means sine of pi over 2 is 1. Okay? So to find a trig function of a quadrantal, what do I need? I need an ordered pair on that terminal side. Once I have that, then I can find r, and then I can fill it out. Yes?
What about when you have a 0 in the denominator?
Great question. We'll get to that. All right, let's try another one. Okay, I have cotangent of negative 180 degrees. Cotangent of negative 180. What is it I need to be able to find cotangent of negative 180? I need a point on the terminal side. So I need a point on the terminal side. Where is negative 180? Where is it? Yeah, the terminal side ends up being over here, correct? So I need a point that's over there. What's the point over there?
Negative 1, 0.
Negative 1, 0 is an excellent one. Okay, so then what do I need to find? R. So r squared is going to be 1 plus 0, so r again is going to be 1. So then I need to figure out what cotangent is. What's the definition of cotangent? Or let's start with tangent, because it's probably going to be easier. What's tangent? Y over x, so that means cotangent is
X over Y.
x over y. So my x is negative 1, and my y is
0.
0. And this is what Kurt was asking. What happens when 0 is in the denominator?
It doesn't work.
It doesn't work, so what name do we give it? We give it undefined. So cotangent of negative 180 is undefined. Okay, and then let's do one more, and hopefully we'll see that something is happening, or that our options are limited. Let's do cosine of 3 pi over 2. Cosine of 3 pi over 2. So I need to know where is negative. Where is negative 3 pi over 2 at?
90 degrees.
It's 270.
90 degrees is correct. Because if I do negative, it's going to end up there. So this is the terminal side I'm interested in. So what do I need from it?
Point.
I need a point. So what point do I want to choose there?
0.
0 and 1 is a good one. Now, you guys are doing great choosing 1 and negative 1, but you need to realize you can choose any number you want to, just as long as it's on that terminal side. It will always give you the same answer. But it's a lot easier if you choose something that has a 0 and a 1 in it. Well, it has to have a 0 in it, but I would choose the other one to be a 1. So what is r going to end up being? R is going to end up being 1. We should have figured that out by now. So what's the definition of cosine?
X over R.
X over r, so what's my x?
0.
0. What's my r?
1.
1. What is 0 over 1?
0.
0. Does anybody notice what are trig functions of quadrantals? What do they end up equaling? What are our options?
0.
0, 1, undefined, or -1. If you're doing a trig function of a quadrantal, there are only 4 possible answers. 1, -1, 0, or undefined. So if you know you're dealing with a quadrantal, you've got a 25% chance of getting the answer correct. Make sure if it's a quadrantal, you know you have to give me an answer of 0, 1, -1, or undefined. Let's try one more, and then we'll recap and let you get to work.
Yeah.
Alright, so tangent of pi. Tangent of pi. What'd you say? Same thing as 180. So that means my terminal side is over here. So what's my ordered pair I want if I'm over there?
So would it just be like
-1.
1, 0?
-1, 0 is what I want. And what's R going to be? R is going to be 1. What's the definition of tangent? Y over x. So I take my y value, which is 0, over my x value, and I end up with 0. So tangent of pi is equal to 0. Yes.
You really teach your R if you're doing something like this?
If you're doing tangent or cotangent, you don't use your R.
I can do this.
R will always equal 1 if you choose the right point. Okay? Hunter makes a great observation. So far, all of our R's have been equal to 1, and he wanted to know, will R always equal 1? And I said, yes, if you choose the correct points. What do my points always need to look like? Has to involve 0 and 1. So let's talk about our points for each section. What's my point need to be over here?
1, 0.
That one needs to be 1, 0. What does it need to be up here?
0, 1.
0, 1. Over here,
-1, 0.
-1, 0, and down here.
0, -1.
If you choose those 4 points, your R will always be 1. Yes.
Will R still equal 1 if it's like -8, 0? It will be 8 then.
It will be 8. Yes.
Okay.
Your R will always be the absolute value of whatever number is in there besides 0. Because you know 0 is always going to be one of your order paired numbers. Whatever the other number is, that's what R has to be.
How come you oddball out and not do the 0 and 1? You have to say that's different.
That's what he was just saying. Let's say in this case, another number I could have chose was like -10 and 0. So if I chose -10 and 0, that means R squared would be 100 plus 0, and R is going to be 10. Okay, so R is always going to be the absolute value of whatever number is in the problem that's not 0. Okay, but again, if I do the same thing, I take my y value over my x value, I do 0 over -10, I still get 0. So it doesn't matter which number you pick, it will always give you the right answer.
Okay.
Alright, so reference angle, what are my 2 requirements on a reference angle?
Acute and positive.
Acute and positive, okay? And sometimes we have to do what to the original angle? Get it between 0 and 360. Okay, define the 6 trig functions. What do we find first? We got the point on, they give me a point on the terminal side. Once I have my point, what do we find?
Missing side.
Find the missing side, which we're going to label
R.
R. And if I have x, y, and r, what's the definition of sine?
Y over
Y over r, cosine,
X over
x over r, and then everything else falls into place. And then when we're dealing with quadrantals, we want to figure out where our terminal side is on, choose one of those points, figure out what r is, and then find my trig function. That's all there is to it. Alright, page 251, 2 to 24 even is what we're working on. So while you're working on that, I'll come around and show you what you got in your quiz.